Hello there, and welcome to a Gcse history revision tutorial. We're going to be looking at some medicine material today. We're going to be looking at material from 1700 to 1900 and the 1900 to present sections of the course. And we're going to focus on the prevention and cure of disease, and in particular the importance of the discovery of the true causes of disease by Louis Pasteur and then their development by Robert Koch. But as you can see, we'll also have a look at some other discoveries and analyse them in the context of the discovery of the true causes of disease, to really focus in on how important that was. So we're really going to be looking at material and content today. So in order to get the most out of this presentation, to use it to develop your knowledge, what you might like to do is to get hold of some paper or some flashcards. And at the end of each slide, you might like to pause the presentation. The structure of each slide is going to be the same. I'll be using BDI analysis, that's before, development and impact. And at the end of each slide, what you might like to do is to pause and then summarise each bullet point that appears in a maximum of 3 words, 2 to 3 words ideally, and use that to create a series of notes. And then after the presentation's finished, you can use those as a revision tool, so you can review and memorise those flashcards, and then maybe leave it for a couple of days, watch the video again, and use them in an interactive way. Maybe tick off the pieces of content as they're discussed. I'll show you how this might work after the first slide or so. Okay, so here's the big picture of the prevention of disease and the treatments linked to it. We'll follow a timeline through from the late 18th century all the way up to the mid 20th century. So it's a nearly 150-year period that we're going to be looking at. And within this, we'll have a look at how things developed from a place where only partially effective prevention was possible to a position at the end where there was effective prevention and treatment of a whole range of diseases. You can see in the middle of the timeline we've got 1861 and the bacteria. We've got a key moment in history here where the true causes of disease are discovered and proved. So we'll have a look at the work of Edward Jenner and his work on smallpox in 1796. We'll have a look at John Snow and his work on the prevention of cholera in 1854. Then we'll have a look at our key discovery and development, and that's Louis Pasteur's publication of Germ Theory, which is developed by Robert Koch. We'll explore that. And then we'll have a look at 2 pieces of work on penicillin with the work of Alexander Fleming and then Florey and Chain and the development of Fleming's work. So let's have a look at our first major development. So we'll look first at Edward Jenner and his discovery and development of vaccinations against smallpox. Now, before Jenner's work, smallpox was a highly infectious disease that killed tens of thousands of people. And the only way that people could hope to prevent smallpox was to be inoculated, where doctors would place live smallpox matter from scabs of infected people into patients to try to give them protection. Now, this was unsafe because of the variability of the strength of the scab tissue. It was also unclean, as you might imagine. Now, Edward Jenner was a doctor working in Gloucestershire, and this is a rural setting, and the people of Gloucestershire knew that milkmaids didn't tend to get smallpox. Now, this was because what they did get infected with was cowpox, which is a less deadly disease. So Jenner set out to investigate why and whether or not this could be of use. And so he got hold of some cowpox tissue from a milkmaid, and then he injected it underneath the skin of a local boy, and you can see this happening in the bottom picture. And he then repeated this 23 times over, published his findings, and thereby proved that cowpox matter would give immunity from smallpox. Now, this is a huge discovery. It's really important. It made smallpox preventable, leading to the eventual eradication of smallpox. It's now pretty much extinct. However, Jenner did not know about germs. He couldn't explain what was going on. He knew that it worked, but he couldn't explain why. And this limited his importance. It increased opposition to the development of vaccination, and it also meant that vaccination and this technique could only be applied to smallpox. All of the other infectious diseases would not be preventable through cowpox. So just before we go forward, here's what you might like to do with that material. Here's an example. You can see what I've done here is, under our three headings of before, development and impact, I've summarised each point into maybe 2 or 3 words at the most to give myself some notes to refer to for my revision. This is the kind of thing you might like to do moving forward in the slides. Okay, so our next point is going to be John Snow and his prevention of cholera. Notice we're still before a point where the true causes of disease were discovered. So in 1854, John Snow discovered how to prevent cholera. And in doing so, he undermined one of the key explanations of disease at the time, which was miasma theory. So before his work, cholera killed tens of thousands of people. It was particularly prevalent in the towns of the 19th century, where people living in towns and cities were often exposed to drinking polluted water and using other forms of polluted water as well. So what John Snow did was to log what was going on, and you can see some of his work in the bottom image. So he logged deaths from cholera in his local area, which was in Soho in London. And in doing so, he noticed that they centred around one particular water pump in Broad Street. Now he was very clever in this work, because what he noticed was that in some institutions people were dying of cholera, yet in other places where you might expect people to die of cholera, if miasma was to blame, that there was no cholera. So, for example, in a local workhouse there are very few deaths. In a local brewery where they were drinking their own beer rather than the water, there were very few deaths. So the idea that disease would be spread by polluted air, miasma theory, is undermined here. And when John Snow persuaded the authorities to remove the handle from the Broad Street water pump, cholera quickly vanished in the local area, thereby proving that his theory was absolutely correct. So thus, John Snow had found that cholera was a waterborne disease. It was spread by bad water, undermining miasma theory. And this really lent weight to the idea that good sanitation and public health reform was necessary and useful. Now don't get the idea that improvements happened overnight, and again there was opposition to John Snow's ideas, but this led a lot to campaigns to improve public health, and it certainly pushed it up the agenda and made change happen more quickly. So you might like to pause here and maybe make some notes on what we've just covered. Okay, now we're coming now to our key discovery. Now this really is our sort of benchmark moment here, and we're going to split our work here into Louis Pasteur and Robert Koch, and we're going to try to fix the year 1861 as a key year in our studies. Okay, so 1861 marked the publication of Germ Theory by Louis Pasteur. This is important for all kinds of reasons, but we'll go for the fact that this made effective prevention of disease possible. So before Pasteur's work, disease was still being blamed on miasma. Only one vaccination was possible, that was Jenner's vaccination against smallpox. and effective treatments of disease were very rare. So in a series of experiments, Louis Pasteur proved that germs were important for spreading disease. He undermined an existing theory of spontaneous generation, which is where the things kind of automatically went bad, spontaneously, and proved that it was germs that caused decay. Now his work led him from work with brewery, to the French silk industry, to lastly working on people. So he linked germs to diseases in creatures. And a few years later, working with one of his laboratory assistants, he made a chance discovery as to how vaccinations worked and was able to explain Edward Jenner's work. Now the impact here is massive. Pasteur's work meant that effective prevention of disease was now possible. In his own work, he discovered and developed other vaccinations. Rabies is a great example here. And he disproved two of the leading ideas around disease and decay, which are spontaneous generation and miasma theory. We might notice, though, that in his early work, what he hadn't done was to link his work in any useful way to humans and human disease. That's going to come next. So here's the researcher who really makes it happen for humans. He does lots of work, and we'll take his 1882 discovery of the tuberculosis bacteria as a benchmark moment. This was the first identification of a germ that affected humans. So in his work, what Koch managed to do was to prove that particular germs caused human disease. So before his work, particular germs had not been identified. Pasteur hadn't been able to do that. So the research regarding germs was very slow, and improvements and developments were very limited. So what Robert Koch managed to do was to identify specific germs. So firstly, he identified the anthrax germ, which affected livestock. You can see in the bottom slide, that's a picture of the anthrax germ. It's actually Koch's picture that he took of it. And then a year later, he discovered the first human disease, and he identified the germ that causes tuberculosis. So he managed to link germs to human disease, and his work here is practical. He managed to isolate and stain particular germs, thereby making it possible for vaccinations to follow. So the impact of Koch's work is that he targeted his research on germs, which made possible all kinds of future discoveries. He also had the effect of spurring on Louis Pasteur. The two weren't mates, they weren't friends, they were rivals. They were both critical of each other's methods. One was German, Koch, one was French, Pasteur, and they really had a fierce rivalry, funded by both of their governments. So this served to sort of spur both of them on to make rapid discoveries. And then Koch's work led to some effective treatments. Magic bullets were specific chemicals that could target particular types of germs in the human body without destroying the body. We'll unpack some of that as we move into our work on penicillin, but you might like to pause here and make some notes on Koch. Okay, so we're going to go beyond germ theory now, and we're going to enter the phase of history where the true causes of disease had been discovered. And we're going to move all the way forward to the late 1920s, into the 30s and the 1940s. Now there's too much to go into here in one presentation, but you can be aware that some specific medicines were discovered in this period, the magic bullets that we just mentioned, where some specific drugs such as salvarsan were discovered and developed, but really on a case-by-case basis. Now, these tended to be antibacterial drugs, but we were still at a point where diseases were being slowly preventable as individual diseases were countered, but effective treatment of a range of diseases was not possible, and this is the importance of penicillin. Okay, so we're going to go to 1928 with Alexander Fleming's discovery of penicillin. So before Fleming's work, there were some, and only a few, effective treatments. Magic bullet drugs such as Salvarsan 606 and some antibacterial drugs. However, many diseases and infections were incurable, and lots of diseases that we would take for granted today as being things that wouldn't kill us. And then in 1928, Alexander Fleming, a researcher in a London hospital, made a chance discovery, where working away in his lab, a penicillin spore seems to have flown in through the window from the laboratory on the floor above and landed in one of his petri dishes. You can see him holding one there. And then what happened is that Fleming noticed that the bacteria that he was working on were countered by the penicillin. You can see this happening in the picture at the bottom. So Fleming noticed this and then started to research the properties of penicillin. And he found that it was effective in countering a whole range of bacteria. However, he found it really tricky to turn this into an effective medicine. Because large quantities of penicillin would be needed to counter a serious infection, Fleming only went as far as to use it as a surface antiseptic, but he did write up his findings. That was a crucial thing that he did. And then he stopped his work on penicillin and left it alone. And again, that's an important point, because that research was going to be picked up by two researchers, Florey and Chain, and they will be using that to turn penicillin into a world-beating drug. And there's a case for limiting Fleming's importance here, because he had stopped his research and was going to go no further with it. Okay, you might like to pause here and make a few quick notes on Alexander Fleming. So let's look at our last development, and we're going to look at the work of Florey and Chain, where they developed penicillin into an effective drug. So, before the work of Florey and Chain, many diseases and infections were incurable, and the overall potential of penicillin was unknown. But as bacteriologists, they found Fleming's work and started to see what they could do with it. And they developed the use of penicillin and researched it in a range of ways that Fleming hadn't done. So firstly, they experimented on using it internally on creatures and found that it would work on small animals. And then they started to grow penicillin. They had a small grant from the British government, not much money around in Britain in the 1930s. So then, in the 1940s, took their work to America to secure large-scale investment and industrial resources. Now at this point, the American government was keen to put money into this research because tens of thousands of Americans were wounded on Second World War battlefields and were also picking up other infections as well as soldiers. So it was also useful against sexually transmitted infections too. So what Florey and Chain managed to do is to turn penicillin from a drug of very limited use that wasn't in production into one that was widely available. And penicillin proved to be an effective treatment against a whole range of bacterial diseases. And of course it's still in use today. So overall their work has saved millions of lives. Okay, you might like to pause here and just capture some notes on Florey and Chain. So that's our big picture there, and you can see we've travelled over 150 years here, and we've got our key moment of 1861, where before that we had Jenner and Snow's work being limited by the lack of understanding of the true causes of disease, and then the way that once we did have the understanding of the true causes of disease, that then led to effective treatments. So that's our key moment in the prevention and treatment of disease in this period. Now we've covered a lot of ground. If you just want to take 3 key points, maybe try these. Firstly, Jenner and Snow's impact was limited by a lack of knowledge of germs. Secondly, you might remember the way that Robert Koch took Louis Pasteur's work on germ theory and applied it to human diseases to his benefit, but also then to the benefit of Louis Pasteur's work too. And then thirdly, the way that effective treatment and cures followed prevention, and the work of penicillin here was absolutely key, with Fleming's chance discovery being developed by Howard Florey and Ernst. Okay, you might want to take this a little bit further. You might have had enough by now, but you might want to take this further. And if you do, here's a 16-mark judgment question for you to have a go at. If you do want to have a go at this, remember, we write introductions for these, then we have 3 topic paragraphs, and then a conclusion. And in our other presentations on the CHSG History channel, we've got lots of guidance of how you structure those answers. Okay, thanks for watching. We've made it to the end. Maybe go back and review this video in a few days' time once you've got your revision cards memorised. Good luck with your revision.